In question 11, a curve has equation y equals kx minus 3 power minus 1 plus kx minus 3 where k is a non-zero constant. In part 1, we have to find the x coordinates of the stationary points in terms of k and determine the nature of each stationary point. Now, to find the stationary point, we'll first have to find the dy dx and then set it equals to 0. So the equation is y equals to kx minus 3 minus 1 plus kx minus 3. Finding the dy dx, so the dy dx will be equals to, we'll multiply minus 1 with the coefficient. So this will become minus 1 into kx minus 3. The power will decrease by 1, it will become a minus 2. And we also multiply it with the derivative of kx minus 3, which will be k. Differentiating kx minus 3, that will become a k. Now for stationary point, we'll set dy dx equals to 0. So this will become minus k up, and we can write it as k x minus 3 whole squared in the denominator plus k equals to 0. Taking k on the right hand side, we'll get minus k is equals to minus k upon kx minus 3 whole squared. K and k will cancel out and the negative signs will also cancel out. So we'll get kx minus 3 whole squared. When we cross multiply, that will be equals to 1. Now to find the value of x in terms of k, we'll square root both the sides. So we'll get kx minus 3 will be equals to plus minus 1. So kx minus 3 will be equals to positive 1 and kx minus 3 will be equals to negative 1. So this will become kx is equals to 4. So x value will be 4 upon k. And over here, taking 3 on the right hand side, that will become kx is equals to 2. So x will be equals to 2 upon k. Now, to find the nature of the stationary point, we'll have to differentiate the expression for dy dx and then substitute these values of k. So first finding the double derivative. So d square y upon dx square, that will be equals to multiplying minus 2 by minus 1, that will become a plus 2 into kx minus 3. The power will decrease by 1 and become a minus 3. And we'll again multiply it with so this k was already over here and we'll multiply it with k again. So that will become k squared. So this will become k squared and differentiating k, that will become a plus 1. Once we have the double derivative, now we can substitute the value of x over here. So substituting x is equals to 4 upon k over here, this will become 2 into, so this will become 2 into, in place of x, we'll have 4 upon k multiplied by k minus 3 to the power minus 3 multiplied by k squared plus 1. So k and k will cancel out. We'll have 4 minus 3, which is 1. So that will become 2 into 1 to the power minus 3 into k squared plus 1. So this will be, when we substitute 4 upon k as a value of x, we'll get a positive value over here to k squared plus 1. So as d squared y upon dx squared is greater than 0, so it will be a minimum point when x is equals to 4 upon k. Now substituting x is equals to 2 upon k, so substituting x is equals to, okay, and one correction over here, as k is a constant over here, so when we differentiate k, that will become a 0. So this will remain as 2k squared into 4x 4 into kx minus 3 to the power minus 3. Now substituting x is equals to 2 upon k into the expression, so d square y upon dx squared, so this would have become a plus 0 over here. So d square y upon dx squared, this will be 2 into, so that was k squared. In place of x, we'll substitute 2 upon k multiplied by k minus 3 to the power minus 3. So this will become 2k squared. 2 minus 3 is minus 1. Minus 1 to the power minus 3 will be a negative answer. So this will be minus 2k squared. Now, as this is less than 0, so when d squared y upon dx squared, or the double derivative, is less than 0, it is a maximum point. So we can say it is a max when x is equals to 2 upon k. Now in part 2, it says the diagram shows part of the curve for the case when k equals to 1. We have to find the volume obtained when the region between the curve and the line is rotated through 360 degrees above the y-axis. Now the formula to find volume, so volume is equals to pi multiplied by the square of the equation and the limits b and a. So the limits in this case will be 2 and 0 as given in the question. So the limits are 2 and 0. The equation is x minus 3 power minus 1. So the equation is x minus 3 power minus 1 plus x minus 3, and we'll whole square it first and then integrate it. So to whole square this, we can treat this as an a squared plus b whole squared equation. So this will become a squared. So that will be x minus 3 power minus 1 whole squared plus 2 into a, which is x minus 3 power minus 1, into b, which is x minus 3 plus x minus 3 whole squared. Now, whole squaring this will become x minus 3 to the power minus 2 plus x minus 3 power minus 1, and x minus 3 will become 2, and this will remain as x minus 3 whole squared. Now, once we have whole squared the equation, we'll integrate this expression and then apply the limits, which are 2 and 0. So integrating x minus 3 to the power minus 2, we increase the power by 1, that will become a minus 1, and we divide by the new power, which is minus 1. Integrating 2, that will become 2x, and integrating x minus 3 whole square, that will become x minus 3 whole cube upon 3. So once we have integrated, now we can apply the limits. So the upper limit is x equals to 2. So this will become 2 minus 3 to the power minus 1 upon minus 1 plus 2 into 2 plus 2 minus 3 whole cube upon 3. And now substituting the lower limit, which is x equals to 0. So we'll subtract it from the upper limit. That will become 0 minus 3 to the power minus 1 upon minus 1 plus 2 into 0 plus 0 minus 3 whole cube upon 3. Simplifying this, we'll get, this will become minus 1 upon minus 1. This will become a 1 plus 4. And this will become 2 minus 3 whole cube. So that will become 1 cube, which is 1. So this will become 1 upon 3. And we'll subtract it from the lower limit. So this will be minus 3 to the power minus 1. So we can bring it in the denominator and write it as minus 1 upon 3. And this will become plus 20, and this will become minus 27 upon 3. So simplifying this, we'll get 5 plus 1 upon 3. And this will become minus 1 upon 3. So this is, and this minus sign remains over here as this was a minus. So this will become minus 1. So minus 1 plus 4, that will become positive 3. And this will become minus 1 upon 3 and minus 27 upon 3. Opening up the brackets and simplifying this. So the final volume, when we add it up, so this will become 5 plus 1 upon 3 minus 1 upon 3 minus 27 upon 3. So that will become, when we simplify this will be 40 upon 3, and we'll add pi to the final answer. So this will become 40 pi. 40 pi upon 3 as the volume of the shaded region. Now, just for confirmation, this was minus, we can simplify this to write it as minus 1 upon x minus 3. This will be 2x over here, and this is x minus 3 whole cube upon 3. Now, when we substitute x equals to 2 over here, so that will become minus 1 upon 2 minus 3. So that would have been a plus 1. So this will become positive 5 plus 1 upon 3. And this, when we substitute x equals to 0 over here, so this will be minus 1 upon minus 3. So this would have also become a plus 1 upon 3. So this would have become a plus 1 upon 3 over here. And this is 1 upon 3 minus 9. So 5 times 3 is 15. 15 plus 1 is 16 upon 3. And this would have been 1 minus 27 upon 3. So this is 16 upon 3 minus. So this will become 1 minus 27, which is minus. So 1 minus 27 is minus 26. And one correction over here again, this would have been a negative 1 upon 3. As x was 2 over here, so this would have been a minus 1 upon 3. So this will become 1 plus 4 minus 1 upon 3. And this will be, so simplifying this would have been 14 upon 3. And this will become minus 26 upon 3. Adding these two up, we'll get 40 upon 3. And then we add pi to the final answer. So the final volume will be 40 upon 3 pi.